All right, so we're talking about the video or the warm up here, and so I wanted to help you a little bit with that. We've dealt with square roots before, and this is what we call a radical, which is great if it's a perfect square. We can easily do that. Like the square root of 100 is equal to 10 because 10 times 10 is 100. The square root of 49 is going to be equal to 7 because it's also a perfect square because 7 times 7 equals 49. But you have something like the square root of 32, that's not a perfect square. 25 is a perfect square, 36 is a perfect square, but 32 is not. However, there is a perfect square hiding within that. And so if we break apart 32, 16 times 2 is the same thing as 32. And so what I can do is I can break this apart and do the square root of 16 times 2. And I can even break it apart more and do the square root of 16 times the square root of 2. Okay? Well, the square root of 16 is just 4, because 4 times 4 is 16. The square root of 2 is not perfect, so we just leave it there and it's attached. And that gives us the answer that we need. The interesting thing about this radical symbol is if you remember our exponents, this is an exponent of a half. So another way to write the square root of 49 is 49 to the half power. And so that's the same thing for that. Okay? So with that in mind, let's take a look at the warm-up. So let's take a look at the first one. So we have the square root of 12 x cubed y to the 8th z squared. And we said we could break this up. So I'm going to break it up into the square root of 12 times the square root of x cubed times the square root of y to the 8th times the square root of z squared. Okay? Well, 12 is not a perfect square, but 4 times 3 has a perfect square in it. So the square root of 4 times the square root of 3. Okay? X cubed is not a perfect square, but it can be broken up into x squared times the square root of x. Okay? Y to the 8th doesn't seem like it's a perfect square, but it is, because I'd have y squared, y squared, y squared, y squared. So really, I can just take the square root, or half of that, of y to the 8th here in just a minute. And same thing with the z squared. Okay? So, square root of 4 is going to be 2. The square root of x squared is just x. The square root of y to the 8th is y to the 4th. And the square root of z squared is z. Okay, so notice, square root. I took the square root. Basically, I just took that in half. Same thing here, took that in half. Same thing here, took that in half. I didn't use this one or this one. Okay, and so we put those together in the radical. And so our answer is going to be 2x y to the 4th z times the square root of 3x. Seems like a crazy little answer there, but that is what it's going to be. Okay? All right, so let's take a look at the next one. We already have something on the outside. It's like 5y times all of this. So I'm going to break up, 125 is not a perfect square, but I can break it up into 25 times 5, right? And then x to the 6th, that's an even amount, so no problem there. Y to the 4th and y to give me y to the 5th. Okay, and the reason I broke it up into the 4th and the 1 is to get me the 5th, because the 4th, I can take the square root of the 4th. Okay, so I have this 5y already out here. I can pull out another 5, because the square root of 25 is 5. I can pull this x cubed out, because that's just going to be half of that. And then y squared would be half of that. I'm still left inside with this other 5 and y. Okay? So I took half, pulled them out, took the square root of that, pulled it out. Now I got to clean up this outside because this kind of looks weird. But I have a 5y times 5x cubed y squared. Well, 5 and 5 is 25. I have x cubed, and then I have y cubed because there's 1 and then 2 more here, times y, or 5, square root of 5y. That's the answer that I should have. Okay, we hadn't worked on that. This is something we were going to do after we had taken our STAR test. And so just wanted to introduce it to you so you had it. The rest of the assignment is dealing with the quadratic formula, which we have done. You might need to look that up, watch the video. We can use it to solve, but you can also check yourself with Desmos, so make sure you do that. Okay, hope this helps.